This is video on friction. This is the fourth video in the series. First video dealt with basics, and second and third, and now this video are dealing with problems. So that way, this is third video on the problems and fourth video on total series of friction. Have a look at problem. It says determine the force P to cause motion to impend. Means just get started. Take masses of blocks A and B as 9 kg and 4 kg respectively, and the coefficient of sliding friction is 0.25. The force P and the ropes are parallel to inclined plane. Okay. Now, see here, when P moves down, B goes up, and that's the only way this system can move. No way A can go up. Okay, particularly when you're trying to pull it with force P down. Now, the steps are: first, draw the free bodies of all the bodies, and we'll take G as 10 so that our weights will come 90 and 40. Now, free body of B has a weight, the reaction, and this tension. And similarly here also, for body A, there is a weight, there is normal reaction, and there is tension, and there is this force P. In addition to these, both these free bodies will have frictional force at the surface. Now, I want you to note the direction of friction. Because A wants to go down, friction is opposing it, it's up. Because when A goes down, B automatically goes up, and therefore friction is down. Now that you have drawn all the free bodies, you have to write sigma fx, sigma fy equal to 0 for both these bodies. And when body is on inclined plane and the sides of the body are parallel to the incline, it is convenient to take x-axis along the incline and y-axis perpendicular to the incline. So if we do that, we can write sigma fx equal to 0, telling us t minus 0.25 R1 minus this 40 sine 30 equal to 0. Now, direction of motion we take as positive. So, since B is going up, all forces in upward direction here or towards our right are positive, towards our left are negative, and that's how these positive and negative signs are coming. Sigma Fy equal to 0 is simple, R1 minus 40 cos 30 is 0. And similarly, we write for this, P minus T. P is positive and T is negative because now motion is in the direction of P for block A. Minus 0.25 R2 plus this 90 sine 30. That is component of 90 along the plane. And then R2 minus 90 cos 30 is 0. These four equations we need to solve. What we'll find is second equation gives us R1, putting that in first equation gives us T, and using this value of T here, we can work out using 3 and 4 R2 and P, in which P is of interest. So this is what they wanted. What is the value of P? We have found it here. Look at the next problem. It says find the maximum and minimum value of W1 for the equilibrium of the system shown in figure. Take W2 as 2.5 kilonewton. Now, to get a maximum or minimum value of this weight W1, we need to do the problem twice. Once we assume motion direction in this manner. Second, so this is for minimum. Obviously, when W1 is minimum, motion will be this way. When W1 is maximum, motion will be this way. Now here they are talking of equilibrium. What we mean is the tendency of motion when equilibrium is about to break. Okay, so because see this direction of tendency of motion or actual motion is important for us to decide on direction of frictional force. The rest all steps are similar to previous problem, that is you draw all the forces for each of them, the weight, the reaction and the tension, and you draw friction directions correctly. 0.25 R2, 0.25 R1, and both are in opposite direction of the tendency of the motion. For 2 it is up, for 1 it is down. Now again, we write sigma fx0, sigma fy equal to 0, taking this for body 1, inclined plane's direction as x-axis and perpendicular to that as y-axis. If I do that, I'll get t minus 0.25 R1 minus W1 sine 30 is 0. Again, I must explain that why we have taken t positive is because for this, upward direction is the direction of motion. So all forces in that direction will be positive and downward will be negative. And then here R1 minus W1 cos 30 is 0. And here it will be minus t, because now motion is downwards, t is in the opposite direction. And this 2.5 sine 30's component becomes positive here, and friction is upwards, so it is negative. And then there is y direction equation. So you have these 4 equations, we need to solve them. What we find is solving 4 gives R2 straight away. And if you put that R2's value here in 3, we get t straight away. Now using the value of t here and using 1 and 2, we can solve for R1 and W1 is of interest, which comes to 1.85 and which is the minimum value of the load W. Now if you want maximum value, you have to repeat the problem with thinking that the tendency of motion in exactly opposite direction. See the next slide. This way it will be. So only difference in the whole game will be the direction of friction. It will oppose, you see, this tendency of motion. Rest all will be exactly similar. What I mean is equation writing and then solving and then getting value of W1, which is 7.8 newtons. So that will be the, I think it will be 7.8 kilonewtons. This needs to be corrected to not newtons but kilonewtons, and that will be the maximum value of W. So please note this correction. Kilonewton it should be. Okay. Thank you.